Hi, I'm Tabitha Ogilvie. I'm a second year CDT student, and this poster is based on a paper accepted to WHAC 2020, which is the workshop on encrypted computing and applied homomorphic cryptography, written with my supervisor Rachel Player and Joe Rao. So to talk you through a little bit of the motivational context, we were really thinking about outsourced computation or cloud computation. So cloud computation is a really good way to use really high computational resources without having to have them locally and perhaps for one-off computation. And so they give you great utility. But when you think about privacy, you're actually sending a lot of data over to the cloud. And that's great if the cloud is hosted by you or your organization, but perhaps if it's a third party, that's not so great. So in this work, we wanted to think about, can we still have that utility without losing the privacy? And specifically, we're thinking about outsourcing machine learning training, but keeping the data encrypted. So what did we actually contribute in this work? Well, we looked at logistic and ridge regression. And for training logistic regression models, we observed high accuracy, fast run times, and high security. While for ridge regression, we saw those same fast run times, high security, but the accuracy was a lot lower. And as far as we know, we're the first people to achieve any kind of ridge regression training in this manner. So the technology we use is homomorphic encryption. What is homomorphic encryption? It's a type of encryption that allows you to compute on encrypted data without decryption. So if you're given a function f and an encryption of a piece of data x, you should be able to generate an encryption of f of x without just decrypting the data. And I wanted to show you this graph, which is kind of how homomorphic encryption is perceived by practitioners of outside of HE at the moment, which is it gives you really, really strong privacy guarantees, but maybe it's not got the same utility as other less secure solutions. And so in this work, we're really trying to push this. As you see from the orange arrow, we're trying to present methods that mean that homomorphic encryption is as secure, but it has the utility to be able to train models. Okay, a little bit more detail on those methods that we use. So logistic and ridge regression both require you to minimize a cost function. We looked at 3 different cost functions. Gradient descent and Nesterov accelerated gradient descent are both first order methods and had been considered in the literature before. The third is an approximation of a fixed Hessian method. So a Hessian method is a second order method. We approximate it to make it easier to calculate. And this method had been considered a little bit in the literature, but we decided to revisit it, update it, and adapt it to a new scheme. So what results did we see? Well, for logistic regression, we looked at the Edinburgh data set, which is a medical data set. And for this, you can see if you experiment in the clear, you can see a maximum accuracy of around 91%. We weren't able to get 91, but we could get about 88 to 89, and in less than a second per fold for Nesterov and fixed Hessian, with that highlight being at the bottom, less than 30 seconds per fold on the fixed Hessian at 40-bit precision. For ridge regression, we use the Boston housing data set, which exhibits a maximum cross-validation R-squared of 0.7. We weren't able to get as close. The highest we saw was 0.45. And it's taking a lot longer. So we believe this discrepancy is because ridge regression converges a lot slower. So you need a lot more iterations than is possible with current HE schemes. So in future work, we'd really like to investigate different methods for the ridge regression, possibly involving matrix inversion. Thank you for your time. If you have any questions about this work, outsourced computation using homomorphic encryption or homomorphic encryption in general, please send me a message. If you'd like to see the full presentation, which we give at WHAC, I'm sure I'll be able to send you a link if you just drop me a line. Thanks for listening.